Hello, folks, and welcome to another episode of Working Problems Out with Mr. Anderson. We're looking at from our physics homework that we had over Chapter 4, Section 2, Newton's first law of motion, I believe, and we're looking at page 128, number 3, okay? And with this problem, here's what we basically had, okay? We had our sailboat hanging out right here, which I'm drawing in our diagram first. All right, I've already read through the problem twice, and when I'm looking at it, it said that the sailboat was experiencing two forces acting on it. One force was to the north, and that was the force of the wind, and that force was equal to 452 newtons. Another force was also acting on this, and this was the force of the water, and that was directly to the west. And so we had the force of the water going this way, assuming that up is north and to our left would be west. And this force of the water was equal to 325 newtons, okay? And they wanted us to find two things, okay? They wanted us to find the relative direction and the magnitude. So how much was the net overall force and what was that direction of the force, all right? So the secondary diagram that we're putting is we're going to need to add these vectors together. When you add them, you always go from head to tail. So when I take these forces, I can put my force of the wind like this, and then the force of the water going directly over here. So what we're trying to find is this side right here. This is what we're trying to find, our resultant vector, all right? Our resultant vector, this force vector. And we're also wanting to find this angle theta. Okay, so since we know this side, and again that's our force of the water, and we also know this side, which is our force of the wind. Now this forms a right triangle. How do we know that? Because this is directly north, and then this is directly west. So that's a right triangle that we have here. So we can use the equation of a squared plus b squared equals c squared, where a and b are just the sides of your triangle, while c is the hypotenuse of the right triangle we formed here, which is our resultant vector force that we're trying to put in place. So that's an equation that will certainly help us here, okay? And so we can go ahead and change those variables. We'll go ahead and change the a squared into the force of the water squared plus the force of the wind squared equals our what do we want to call this one? I guess we'll call this our net force, because that's our overall force, so our force net squared. Now we'll use this guy later on in our equation here. Another equation that will help us is we need to solve for this angle, so angle theta. And we know, since this is where we're looking at with our angle, we know the opposite and we know the adjacent. So we have opposite and adjacent. So opposite and adjacent would be, for our sine, it's SOHCAHTOA, all right? So opposite and adjacent is tangent. So we'll be using the tangent function here to help us. So tangent theta equals opposite over adjacent, where if we change our variables here, our opposite is the force of the wind, force of the water. Now let me fix that up. Force of the water over adjacent is the force of the wind. Okay, so we'll use tangent theta equals force of the water over the force of the wind. And remember, since you're watching this on YouTube, you can fast forward, rewind, pause, do all those things, all right? So if it seems like I'm going too slow, speed up. Going too fast, pause a little bit, write things down. So those equations, here are the guys that we're going to use. Now our next step after we write our equations in is doing algebraic manipulation. So when we're doing algebraic manipulation, we'll take this equation first. So that's force of the water squared plus force of the wind squared equals our net force, that resultant vector we're trying to find squared. So we need to isolate this guy and get it by itself, all right? So that means that what we'll need to do is square root both sides, because we just did the opposite of squared. Those cancel out. So when I flip and rewrite the equation, it becomes our net force is equal to the square root of the force of the water squared plus the force of the wind squared. Okay, so we'll use that equation here momentarily. Our other one for solving for angle theta, remember that we had it written out as tangent theta equals the force of the water divided by the force of the wind. And since we need to get theta by itself, that means we need to divide by tangent, since it's being multiplied here by theta. So those cancel out, and then we're going to divide the other side by tangent, because whatever you do to one side, you have to do the other. Now, we can rewrite this as such, where it becomes theta equals the inverse of tangent times the force of the water divided by the force of the wind, all right? Now, remember that when you're entering this into your calculator, sure you'll have to do the unit analysis step, but when you're entering this into your calculator, you're going to actually use the inverse tangent function. So you'd be like second tangent, and then this little open parenthesis will pop up, the force of the water divided by the force of the wind, close parenthesis, equals. Okay, so that's what you'll need to do when you're entering this into your calculator. Now for unit analysis, let's check out the units we're working with. Now, since our forces of the wind and the water are in newtons, well, guess what? Our net force is also going to be in newtons. So, newtons, our net force, is going to equal the square root of force for water is going to be in newtons. That'll be squared. Plus the force for a wind, that's in newtons. That'll be squared. So, since these are squared, these terms are squared and they're the same, we can put them together. So that becomes newtons equals the square root of newtons squared, where our square root and the squared cancel out. And so that's, newtons equal newtons, all right? Now for the unit analysis step over here, our theta, well, that's going to be in degrees, right? And then our inverse tangent is a function, so there aren't units that we'll be putting on that guy. The force for our water divided by the force of the wind, where the force of the water is going to be in newtons and the force of the wind is in newtons. So remember, when I was telling you about when you're using this tangent function to find your angle theta, this tangent function will always turn the ratio of your sides when used properly into degrees, as long as these units are exactly the same. So since these units are the same, they cancel out and just gives us a pure ratio that we can turn from a ratio into our degrees. Remember, though, that when you're plugging this in the substitution and solution step, that you need to make sure that your calculator is set for degrees, not radians, not graduations, just degrees, okay? So make sure your calculator's degrees. And then from here, it's just going to be amount of substitution and solution. So plug and chug. I'm sure you can take care of the rest. If you need more help than that, please come see me, and I'd love to work with you one-on-one.